and welcome to today's session. Today's session we will discuss about the module 3 model question papers and previous year question papers questions with solutions. So let's begin. This is the first question. Define list. List out the important features of list and demonstrate adding an element to the list using plus operator, append methods and insert methods. So first answer the first question. What is a list? So list in Python is an ordered collection of elements which is referred by a single variable name. Next, point wise you have to write. It's a linear data structure. List can have 0 or more items. It is also called as Python arrays. The constituents of list are called as item or element. And then you have to tell how you can create a list. So write the syntax and write exactly the code for creating a list. You can create an empty list. So if a list is always enclosed between square brackets, so this is an empty list where I just say values and just square brackets. So values is the name of the list and I'm writing the list is empty, so that's why within square brackets we have not put anything. Here in the second example, for the values list I'm putting some values. So values, open the square brackets, and within that you can write the initial values of a list. So therefore this list is created. Next, you have to write the features of the list. So list is mutable, meaning the list contents can be altered. List uses zero-based indexing. In the sense, the index of the first number on the left hand side would start from 0 by default. Objects of any time can be found among them. You can have integers inside your list, you can have strings inside your list, you can have floating point, any kind of object or list within a list, it's possible. Indexing will provide quick and easy access to the list. There is no cap on the number of sublists that you can be encapsulated inside a single list. You can have lists within a list, and there is no limit of the how many lists you can have. So lists can be of wide range of sizes. Now coming to the next question. Explain plus operator, append and insert methods. So plus operator is nothing but the concatenation operator, where we use this plus operator for performing the list concatenation. Concatenation means we are going to join two lists. So this is the syntax for concatenating two lists, list 1 plus list 2. So what does this do? So when we do this, suppose let's say take an example and explain. Let's say I have two lists. Items 1 is containing two items. This is the list zinc and copper. Items 2 is equal to, within square brackets you write the string. As I said, list can also have strings inside it. So this is the concatenation. If I write items 1 plus items 2, it concatenates the two strings, two list, and this is the output that you get. This is an example of list concatenation. The second question is append. So append function, it's a function which is used in Python to populate a list. See, for the previous example, suppose this is what we have. We already have items 1 plus item 2 like this. Now for items 2 is silver. Now upon that, if I use the append function, items 2 dot append, and since it is a function, you pass an argument. Suppose I pass nickel as an argument, and then if I print items 2, I can see that now items 2 list contains silver and nickel. So basically it is used to append items into your list. Now the next method is insert. Now insert method is used to include additional items to a list just like append, but here you specify the position in the argument. So where do you want to append? In the append, what happens? By default the item will get appended at the end, but in insert I have the choice of inserting the element at any position in the list. For example, now items 2 is initially containing silver and nickel. Now upon that I call insert method, and the first argument here you have to give is the index where you want to put this element titanium. Since I gave 0, at the 0th position titanium is added, and this is what you get. This is the final items 2. So explain the method, explain with an example. So that was question 1. Now going to question 2. Write a Python program to read n elements in the list, search for a key in the list using binary search algorithm. So now let's go into binary search algorithm. So what we have to do is, let's first create a list. and within that list I have to search for a particular element, and for searching I'm using the algorithm binary search. So let's go into the algorithm. Let's first try to understand the algorithm. See, there are two types of algorithm: binary search and linear search. Now binary search is more effective because what happens here is the word itself says binary. We are going to split our list into two parts. Either I will search in the first part or in the second part. But in linear search, what happens? The word itself says we search for a key one by one. So we are going to search for a key in the entire list or until we get the item. So binary search is more effective. Let's see how it works. So first thing is, whenever you are using binary search, the list first must be sorted. It has to be in ascending order. Okay, suppose this is the list that we are giving as input, and suppose a question is I want to find the element 45, right? I want to search for the element 45. If it is existing, it should output the position. So what is our position of this? It starts from 0, so 0 1 2 3 4. So if the element is present in the list, it should give the output as 4. So that means this element 45 is present at position 4. If it is not present, the program should say it is not present. So how do we search? Since it is a binary search, here we will be having two pointers. One is low and the other one is high. So initialize both low and high to 0 first. Okay. Next, one more pointer I will be using is mid. So basically to find the midpoint of this of this array. So initialize low to 0 and high will basically containing the end. So in this case low is 0, high would be this one, the position of this. So that is 0 1 2 3 4 5 6. So high would be 6. What is mid value then? 0 plus 6 divided by 2, that is 3. So mid would be the middle, it will point to the middle element in the list. So you're getting 3 point, suppose you get the answer as 3.5 as here, then that's, but I cannot use 0.5, so I just going to use 3. So in that case I will use floor division. Floor division means one more slash here will ensure that I just use the number before the decimal point. So in the code I will be using low plus high floor division 2. So 2 slashes will be there so that I only take the integer part and neglect the decimal part. So once you find the middle number, then you compare. Suppose the middle number is 39. I am searching for 45. Now 45 is greater than 39, right? So therefore it will search in the second part of the binary search, and that's why computationally binary search is more effective, because it is going to search either in the it's going to search either in the first section or in the second section, therefore reducing the number of searches. But the only thing is the list has to be sorted. So now suppose I am searching for 45, it got to know that I am going to search here. So now I will implement linear search. First I will search in the next element. Is it equal to 45? Yes. Since I got 45, now you return the position. Suppose it is not equal, again you go on searching. Then again you increase. So basically once you decide whether you are going to search in the first part or the second part, after that you again apply linear search. Therefore the number of searches is reduced in binary search. Now let's see, this is the diagram, right? So I first initialize low pointer, high pointer. Low is going to point to the first element, high is going to point to the last element in the list. Mid is basically I'm going to calculate which would be the middle point of the list. And then suppose I'm searching for 45, 39 is less than 45, therefore I have to search here in the higher part. Then you search is 45 is equal to this mid, you increase the midpoint. Is mid is equal to 45? Yes, and therefore it returns the position. So now let's go into the Jupyter notebook and implement this. So we have written a function called as binary search, and for that two arguments I'm using list and n. So basically list will going to contain the list of elements, and n is going to basically tell you it returns the index okay, in the given list if present. If the item is present, it will return that. So as I said, I'll be having 3 pointers. Low initially I keep as 0, mid also I keep as 0, and high would be what? It would be it should point to the last element in the list. It should point to the last element. So if I find out the length of this list is 1 2 3 4 5 6 7, it will give, right? Length of list would be 7, but position wise or index wise, it is, since it starts from 0, it would be 6. Therefore that is why we are giving -1 over here. Okay, now coming to the logic, first I am going to check, is low less than or equal to high, right? If it is, then you find out the midpoint. As I said, midpoint would be the average, right? High plus low, floor division by 2, so that I only take the integer part. If the division results in a decimal value, say 3.5, only 3 would be taken. Next, I'm going to start the comparison. I'm going to compare the mid value, right? If list 1 of mid, in this case list 1 of mid is this one, 39. Is it less than n, right? Check if it is less than n. What is n? The element that I'm going to check, I'm going to search. In this case n is 45, right? So is 39 less than 45? Yes. So that means I have to now search in the higher part of the second part of the list. So what I'm going to do is I am going to increment low. Initially low was 0. Next I'm assigning low is equal to I'm going to increment low as mid plus 1. So low is mid plus 1. Mid plus 1, mid is 3. Now low is going to point to 4th. Okay, else if, suppose if n is not greater, I do the reverse. I subtract 1. Else, suppose it's not satisfying either of this condition, that means the value is equal to this. I got the value at mid. Therefore, you return mid. And finally you return here, return -1. Why do we say return -1? If the element was not present in the list, suppose you can have not present, then you say return -1. So this is your total function for binary search. Now coming to the main part of the program, I am going to create a list something like this. Remember, it has to be sorted. That's the condition. And suppose I am finding n is equal to 51. As you can see, I have given a number which is not existing. So then what happens? I am going to call the function. To the function, the first argument I pass is the list. The second argument is the key that I want to search. And whatever is returned from this function would be given to result. What would be written? If the element is not present, -1 would be returned. If the element is present, then it will return the position. Okay, so whatever is written, that would be given to result. Now I'm just going to search. If it is not equal to -1, that means the element is present, right? So I'm going to display it is present at index. What is the index? The index would be given by this function result. So I'm displaying the result as, but I am using str. Since the result is a number, I am going to concatenate with the string. Therefore, it's very important that you do typecasting. You convert your integer to a string so that you can display it as your output. Else, if the result is equal to -1, that means you just display it is not present in the list. Now let's try the execution. So for this, since the element is not present, right, it's saying it's not present. Now let's give a number which is 50, which is present. See, it is saying element is present at index 5, that is this position. Now let's give a number which is in the first. See, it is saying element is present at index 0 if I give 12. Okay, so this is a complete program. If this question is asked, please explain the algorithm in some 4-5 steps. Write the steps and then please write this complete code with the output for all the 3 cases, like just how showed. For the case where the element is not present, for the case where the element is present in the higher part of the list, and for the case when the element is present in the lower part of the index. Only then you get full marks. Now going back to the next question now. So that was the binary search question. Now let's go to the next question. Describe the shallow copy and deep copy operations with respect to data structures like list and tuple. So let's first understand what is deep copy. See, deep copy is used for nested list. Okay, the duplicated copy, as a word itself says, you're going to copy a list, right? But there's a difference. The duplicate in deep copy, what happens is the duplicated variable has its own distinct memory. So it's safe if you make any kind of updations on your deeply copied variable, because that will not go back to the original. So that is about deep copy. Shallow copy is like a carbon copy of the original, and it is not used for nested list, right? If any new variable is altered, the previous one is also modified. Now lists can have shallow copies that are precise replicas of the original list entries. Okay, and to implement this shallow copy and decopy, you have to import the copy module. And if you say copy, if you call the copy function, you'll be implementing the shallow copy. If you call the deep copy, you'll be calling the deep copy function. If you, instead of saying copy function, you can also use the equal to operator. Okay, now let's see a simple code to understand this shallow copy. So let's first see the shallow copy. As a word, as I said, if you are using copy, you have to import this module copy. Now I have created a list. Okay, so list is 11, 22, 33, 44, 55. This is my primary list. Now I am going to copy this into another list. So how do you do shallow copy? Call the name of this list dot copy function. Okay, and the copied value, let's say I'm putting it to shallow copy list. Now we just display how it looks. Okay, next let's try to modify the primary list. What I'm doing, I'm modifying the primary list. My primary list is primary list 1. To that, let's say I'm appending 66. After appending or after updating the primary list, it's very important that you see how the primary list looks and how the original looks and how the copied one looks. So let's execute this. So what do you see now? See, after initially this is our primary list which I appended, right? I appended 66. But what you can see here is, though this is a copy, the original, this did not get updated, right? I updated the primary list, but there is no change in the shallow copy list. So that's the difference. Now coming to deep copy, I'm demonstrating deep copy with a nested list. So this is a nested list, right? This is one list, this is another list, this is another list, which I'm enclosing all within a parent list. Now how do you implement deep copy? Here again it's very important that you import the copy module and then say copy.deepcopy. This is a way you implemented deep copy. Copy.deepcopy, and to this function you give the argument or the list which you want to copy. So I want to copy list 2 into this deep copy list. Next, similarly, let's append the primary list, right? At the 0th position I've appended a value. Now after appending, let's see whether the primary list and deep copy list changed or not. So as you can see here, right, to the primary list I have appended 777, right? Because I said here to the 0th list, that is this one, append 77. That's why it came at the end. But you can see that the deep copy did not get updated. Okay, the copied list did not get updated. So this is the difference between shallow copy and deep copy. So if this question is asked, please explain the concept of deep copy, please explain the concept of shallow copy, and then write the code for each and tell what is the expected output. Now, this is a question that can be asked. They will ask, outline the concept of slicing of a list or a tuple. Okay, you have to explain. They are asking what kind of output you are going to get. See, this is a list. Let's see this in the Jupyter notebook to understand better. They have given a list here. So what are the values? 10, 20.5. There is a complex number here. This list is containing an integer, it's containing a floating point number, it's containing a complex number, it's containing a string, it's also containing another list, right? So it's a nested list. Now they're asking you what is the output of this, right? That's what they asked in the question. List of colon length of list colon, right? So I am giving this print so that you can see the output. So what is this doing, right? As I said, this is a concept of slicing. In slicing, when you do, there are 3 arguments which are possibly given. The first one start, stop, and the second one is the index. Since here you are giving only the middle argument, and the middle argument is the length of the list. Length of the list is 1, 2, 3, 4, 5. So what would be the output? Complete list would be given, because the first argument, the first list index would be taken as 0, the last one would be taken by default as the end one. Therefore what happens? The complete list is printed. In the second one, the first argument is only given, that is 1. So that means now you slice from here, the first index. So therefore the output is from here till here. This is for the second case, C, because I made the first index as 1. Now coming to the next one, here the last index is specified. So that means what? By default it will start from 0 and it will increment by 1, and since it is 2, therefore what happens? 0, 1, 2, right? But what happens is 0, 1, 2, and therefore what happens is this is what is printed, 10, right? What is this actually? This is the step size, right? And therefore what happens? It starts from 0 and it will increment by 2. So that's why you see here 10 is printed, then this is skipped because I gave, this is a step size. Okay, so therefore what happens? The first index is printed, increment by 2, this one is printed, increment by 2, this is printed. Okay, because the third argument is actually the increment steps or the steps. The second one, only 2 arguments are specified, and therefore what happens here is it starts from the second index, that is 0, 1, 2, and it goes on until the fourth index, and increment, since it is not mentioned, by default it will be 1. So therefore 3 plus 5j and Python is printed. This is 0, 1, 2, 3. As I told you, this is the end index. Okay, end index, but it will not go up to 4. Please remember this, 0, 1, 2, 3, 4. This is the fourth one. It will not go up to 4. It will always be 3. Remember this, right? I'll just type here. If you give the index for a list, this will be the start, this will be the end, and this will be the step size. Okay, and always the start by default is 0, end will be the last index, and this would be the way you want to increment. And in this case, since I have just given 2 colon 4, it means step size is not given, end is only given. And always end, whatever number is there, you have to do -1 for this. Please remember this. Okay, since I said 2 colon 4, it actually means you have to print the element at second position and third position. 4 is not printed, remember this. Now coming to the next one, here only the middle argument is given, therefore the default, it starts from 0th position and it increments by a step size of 1, and it will go only up to 3. That's what I'm saying. If the end is 4, it will actually go up to element in the position 3. So 0, 1, 2, 3, only till Python is printed. See. Okay, and the last one, -1, -1. Therefore here, since -1 is there, it means that I'm doing negative indexing. You start from the right hand side. So that means I start from here. This is -1, this is -2, -3, -4, -5. Since here -1 is given, middle one is not given, increment would be by default 1. And therefore everything, you can see that here now, what happens is -1 would be the incrementing size, and the first index is -1. The increment is not, increment is given, but the end is not given. Therefore what happens? 10 is printed, 20.5, 3 plus 5j, Python 10, 20. Everything is printed, but in the reverse order. That's the only difference. So remember this, since I gave -1, it will start indexing from the last. Everything is printed in this case because I gave the start index as -1 and the increment is -1 by default. And since nothing is given, the last index is not given, it will go up to the last element. But only difference is everything is different, displayed in the reverse order. Remember this. Okay, so this was the next question. Now let's go to the next question. Write a Python program to create dictionary and print frequency of every character in that dictionary. Okay, so let's say I have a string like this, right? So I'm going to create a dictionary. Suppose so for that, let me say I'm creating a variable like this. What I'm supposed to do, I want to find out the frequency of every character here, right? So what is a dictionary? Dictionary will have two things. Dictionary, remember, will be enclosed between curly brackets, and it will have two things. The first one would be the key and the second one would be the value. That's a dictionary, right? So dictionary is always enclosed between curly brackets. The first one is the key, the second one is the value, right? So now what I am supposed to do, key would be the character in the string, and I want to display value would be how many times it is printed. For example, here P is printed 2 times, so P2. Y is printed how many times? Once. T is printed how many times? Once. So like that, every character, how many times it would be printed, right? It appears that should be printed in the dictionary. So how do you do this program? So let's say I'm going to keep the output in the frequency. So this is my dictionary. Frequency is going to contain my dictionary. Now let's looping through this S. So character by character I want to do. So let's say for C in S, S is going to contain this entire string input. So if C in frequency, so basically what is this frequency? It's a dictionary, right? It's going to see the first element. So when I write something like this for C in S, it will start looping through this string from the first element and it will go up till the last element by default. Okay, so if C, so first time it will see P. Is P in present in frequency? No, this is the first one, right? So what it will do, I'm going to update frequency of C, that is frequency of, in this case, P. Initially it is 0, so 0 plus 1 is 1. So basically this is an increment operator. Else, if it is not present, you just, if it is not present again, you just make it as 1. That means it is only once present. Suppose this is an in operator. So suppose I y, it is not present, then it will not go into this at all. Okay, so like this you have to, this loop will repeat until it loops through this entire string, and finally you have to print a frequency. You have to do it outside the for loop. Okay, so P is printed 2 times, so that would be taken care of here. So next time again it finds P, already 1, the value of frequency of P is 1, now it will become 2. Okay, so that's how this one. So if you execute this, you can see this is the output you get. So coming to the next question, illustrate the operations for adding an element to the set, removing an element from the set, set union and set intersection. So first explain what is a set, right? So basically set is a list of immutable elements that may or may not be ordered. It can contain various elements. Coming to the first question, adding an element to the set. How do you add element to the set? Use the add function. Okay, and this function will just add an element to the set. It will not return any value. Okay, the element is just added if it is not already present. And this is the syntax. So how do you add elements to the set? The set variable dot add, and within the argument what do you want to add, right? So that I'm going to give in the argument. So this is the syntax. The second question, how do you remove element from the set? When an element is to be removed, you just call the remove function, and then this function, to that you have to pass the element which you want to remove as argument. So this is the here you write remove, don't write discard, just write remove. Okay, the next question, what is set union? This is very similar to the math concept, right? Suppose I have a set called as A, set called as B. A union B would be basically all the elements, the common elements, as well as this part of the A and this part of B. So basically it's a it will contain both the elements of A and B set. Intersection is going to contain the common elements of A and B. So this is how you do union. If you want to find the union of two sets, set1 dot union set2, or you can also use this pipe operator. You have two ways that you can do it. So let's see this example. Suppose I have set1 and this is set2. So this is how you define a set. Now if I say union set1, or you just use a pipe operator set2, this would basically give all the elements of both the sets. Or you can also say set1 dot union of set2. Both of the things are fine. If you want to do intersection, instead of saying union, you write here intersection, or you can do ampersand operator. Okay, so to have union, you can use this union function, or you can use a pipe operator. For intersection, you can use the intersection function, or you can use the ampersand operator, and then finally display. So let's see the output of this, right? So I have two sets here, so let's display the output. see here. So the union of set 1 and set 2 is these two, and this is an intersection. Only one common element I have here is red. So this is how you can do union and intersection of two sets. The next question, explain dictionary and basic operations in dictionary. So first tell what is a dictionary. As I already told you, a dictionary is an unordered collection of items of key and value pair. Right, it is called also called as mapping type. The map type consists of set of element pairs. The first element is a key, the second one is a value. And here when you want to search for any element in a dictionary, you can search using the key value or using the value. And dictionary is always enclosed within curly brackets, and there is a colon which is separating the key and the value pairs. Remember, the key is immutable object, it cannot be changed. What are the basic operations in dictionary? Creation of dictionary, adding elements to dictionary, removing elements, and deletion of dictionary. And this is the syntax, how you create a dictionary, right? Put curly brackets, the first one is key, second one is value, in between you put a colon, and then give one example. So let's say dictionary is equal to some elements, raisins 49 colon, prunes colon 38, apricot colon 53. So just give an example. Next question, define tuple and give the syntax of creating, indexing, and string tuple, and what are the properties. See, what is a tuple? Tuple is a collection of items or elements. It's also a sort of list. Tuple is like list, but it is not list, because the main difference between list and tuples is tuples are immutable, whereas lists are mutable. So that's the main difference between list and tuples. Okay, tuples are immutable, lists are mutable. Mutable means it can be changed. And very important is, how do you identify a tuple? It is enclosed between round brackets and it is separated by a comma. You can also have empty list. How do you write an empty list? Just write two parentheses like this. And it can also have a single element. A tuple with a single element is called a singleton. And this is an example. You have a tuple here, right? How do you create a tuple? Enclosed between parentheses, and these are the elements. And if we just print this, this is printed. So next question, how do you create a tuple? So when this question is asked, first write the syntax, then write an example. Syntax is very easy. Variable name is equal to open and close the brackets, parenthesis, and give all the elements separated by comma. This is an example. You can have, this is an example of an empty list. This is an example of a list with just one single element. Next question, indexing of tuple. How do you index? So give the name of the tuple, and within the square brackets give the index. So indexing, suppose I have created a tuple like this, and catalog is the value that I have in my list. See, indexing is from the left hand side, it will start from 0 if you do the indexing, and it will go on incrementing by 1. If I want to do indexing from the right hand side, it will start from -1, -2, -3, and goes on incrementing like this. So coming to the tuple indexing, as I told you, if I have a tuple like this, if I want to access this first element, you have to say t of 0. 0 should be enclosed within square brackets. If I want to access this fifth element, say t of -1, again within square brackets. So this is a way you can access the elements of a list using indexing. Next, string tuple. String tuple means what? Within a tuple, all the elements are strings like this. Okay, and how do you access? Similarly, right? If I t of 0 will give apple, t of -1 will give grapes, t of 4, 0, 1, 2, 3, 4, t of 4 will give grapes again. So next question, write a Python program for printing 4 fruits with their varieties and calorie content using nested dictionary. So I have to write a program for printing 4 fruits. So let's go to the program. Okay, so what was the question? You have to print 4 fruits, and the 4 fruits should have the variety and calorie content, and I have to use nested dictionary. So let's create a nested dictionary. Dictionary, as I said, should be enclosed within curly brackets, and within that I have created 4 dictionaries again. Okay, this is the first dictionary for apple, the second one for banana, third one for mango, then grapes, and within that apple I have the values again as a one more dictionary, right? Color is red, calorie is 80. So what I've done within apple is the key. Under that I have one more dictionary as a value. Banana is a key. Under that I have one more dictionary as a value, and under that I again have, like, color is a key and this is a value. Calorie is a key, this is a value. So I'm saying apple is red color, calorie is 80. Banana is yellow color, calorie is 110. Mango is yellow color, calorie is 60. Grapes is orange color. Okay, grapes is, let's say, purple color, and calories 90. Now, how do you print it? Suppose I want to print the color of apple. How do you do? Write the name of the dictionary within square brackets apple. So this will give the access to the first key, and within this I want to see color. So you write your color. Suppose I want to see the calorie of banana. So give banana as a first index, calorie as a second index. So when you execute this, you can see apple color is red, banana calorie is 110. So this is a way you can create nested dictionaries. Now explain pop and pop item methods in Python. Okay. Now pop function is used to remove an element within a list using the pop method. If the index is known, it modifies the element at that position. It removes that and returns the last element. Okay, and this is the syntax. The list name dot pop function. Suppose I have a let's say a dictionary like this, and upon that I write the pop function, and I'm mentioning the key value. Therefore what happens? This value, it will pop out. The pop item, it removes an arbitrary item from a dictionary. So arbitrary in the sense, see the same example I have taken and I am saying nothing. I am not specifying any index, and therefore what happens is it removes an arbitrary item from a dictionary. Let's execute this to understand better. So this is a pop method. See, I've created a dictionary like this. When I say pop of 2, so it will pop out this element. Okay, see, it will pop out this element. So let's say I want to display fruits again. See, what has happened is it has popped out this element, and therefore after popping, fruit is only containing these two. This has been removed. Okay, so pop function has removed the element from the dictionary at the index which was at the key value which was specified. Now what does pop this one do? Let's call this as fruits 1 and this as fruits 1. What does this do? I am having the same kind of dictionary, but pop item, when I say, I am not going to mention any item which has to be removed, any index. So it will arbitrarily remove. And if I want to display this, let's see. See what has happened? It has arbitrarily removed the last element, and if you display fruits 1, only these two are there. So coming to the next question, define list and properties of a list. They can ask you some code, right? Define list, properties of list I've already discussed in the first question. Coming to the second part, predict the output of this. Let's go to the list output. Okay, so I have a list here like this. They have given you a list 1, they have given to list 2. They have asked you to guess the output. So coming to the first one, list 2 into 3. So basically what does it do is it what you can say replicates, right? 359 would be duplicated 3 times. So this would be the output. 359, 359, 359. 3 times you can see list 2. The second one, list 1 plus list 2. So basically this is a list concatenation. Therefore 359 would be added to the end of the list. So this is the list 1, this is the list 2. So it will be concatenated. Now coming to the third one, colon minus 2. So that means what? The start index is not given, end index is also not given. So start index by default would be 0. End index means it will go to the end, and the step size is minus 2. Therefore what happens is list 1 is it starts from first, but okay, since it is minus 2, reverse will happen. See, 49 will come, next 42, right? It is going incrementing by step size of 2. Next 39 would be printed, next 67, next 23, next 45, next 7. See, this is the output you get. Because I gave minus 2, it will start the indexing from the right hand side. The next one, list 1 4 to 12. So it's very easy. 0, 1, 2, 3, 4. It starts from 13 and it will go up to 11, not 12. Remember that. So this is 4, 5, 6, 7, 8, 9, 10, 11. So 45 to 42 should be printed. Okay, sorry, 13 to 42 should be printed. Next, the last one, this one, colon minus 2. So therefore what happened here? Again, here it would be the step size is minus 2, and this I'm doing on list 1. So what happens here is, again, since the first 2 arguments are not given, it's just going on like this: 12, right, 7, 11, okay, 45, so it's going up to 42, it will come. The last one, 89 in list 1. So basically it is a in. Is it checking that 89 is present in the list 1? If it is present, it will give true. If it is not present, it gives false. Since 89 is present here, the output would be true. Coming to the next question, they've asked you to write a program, Python program to change the value Wednesday to Tuesday in the following dictionary. So they have only given you a dictionary. So how do you change it? Very easy. So take they have given you the dictionary. They just asked you to change Wednesday. How do you change? What is the index key value? 3. So just say days of 3 is equal to Tuesday, and it will change. See. So just say days of 3. 3 is the key and change the value. It will change. Predict the output of the following code. So they've given you a code lump, something like this. This is a dictionary, and they said if I pop out y from this, right? From this dictionary, I have to pop out y. So what happens if you pop out? That will be removed, and therefore the output of D would be now having x and z. This will not be there. That's all. Now coming to the next question. Use dictionary to help a Python program determine and print number of duplicate words in a sentence. So you have to find duplicate words in a sentence. Let's go to the code. So I have to write a program to print the duplicate words in a sentence. Suppose I am going to have a dictionary like this, right? I've created a dictionary. In this dictionary, because they said use dictionary, right? So here apple is there, here again apple is there, banana is there here in position in key 2 as well as in key 5. As I told you, in dictionary keys have to be unique. You cannot repeat, but values can repeat. Apple is there once and orange is there once. So what output I'm supposed to get? It should say apple is coming twice, banana is coming twice, the rest all is coming once. So how do you do it? Actually in Python there is a module called as counter, so which is under collections, right? So from collections import counter, if you just call the counter function, it will do the job for you in one line, right? You don't have to write special code. So counter, and in that you give words, right? And this will give the word count. So when you execute this, you can see here what is the counter returning. See, 4:orange, 4:orange. It's just once, therefore it's not telling you that. But 2:banana, right, and 5:banana is 2:banana, it is in, and 5:banana, they are separated here, and apple again it is printed. So apple is 1, it's there here as well as here. So basically it is putting all the duplicate words in different it's basically printing the word count, right? So orange is here, banana is only once, banana is twice, apple is thrice. So that's it. So this was just a quick revision of some of the previous year question papers and model question papers. So please refer this, but this is just a sample. You have to go through the actual complete syllabus for your exams, but this will help you to prepare for your examinations. So all the best. Thank you very much.